So here we are, my good YouTubers, we're back again. I have gone ahead and trimmed our M3.5 screws. This is one handy bit of electrician's kit, this is a CK cutters 31008. It allows you to wire strip 1.5mm squared and 2.5mm squared cable in the indentation. You've got your cutters. You've got squashes and crimps here. You've also got this hole right here, which is for your 3.5 screws, so you can cut your screws nice and accurately by sticking them in the hole here until it lines up. Of course, it goes in and you cut like that. As you can see, there's the old piece there, there's the other piece here, and there you go, perfectly cuts the nickel brass or nickel plated brass 3.5 screws. To get this one was a bit short because obviously that's just an offcut, but you can just poke that out quite easily, just like so, and you have your screws cut. No fuss, no hassle, no hacksaw needed. Now let's continue on and assemble the unit. The beauty of those cutters as well is the fact that they leave a nice clean cut to the thread, so it makes it a little easier after they've been cut to be able to screw them in, you see. Unlike if you'd cut them just with the normal cutter section of your cutters, it would sort of squeeze out and leave partial threads, and which would be difficult. You'd have to file the ends off to clean them up, rather than with this it sort of makes it a much more cleaner cut, so that you can start the thread easy, he says. There we are. Let's get it lined up correctly. Splendid stuff. That's the two top ones now. Again, because these are nickel plated brass, they're also easy to solder to. Unlike if you used zinc plated or stainless steel screws, you know, you have the difficulty of come on, get in the slot. Having difficulty with my screwdriver here. Oh, this one's got a, there we go. It's a slightly tight slot. As I say, I'm obviously using a normal screwdriver. Usually, sometimes with the electric screwdrivers, that's what these are sort of designed for. They tend to be a bit thinner blades sometimes, rather than with these generic cheapo screwdriver that I've got here. They're a bit you know, a bit thick on the blade, because they make them so cheap out of cheap materials. They need to make them thicker, otherwise they'll bend and go all messy. Doesn't want to let's loosen these a little down here, gives us a little more play. Stop being an absolute pig. I need a slightly thinner blade, I think. Thinner bladed screwdriver. One of these here. There we are. always one. There we go. Found its home in the end. That's a bit literally such a tight fit, this screwdriver into the slot, which is not a bad thing, but when you're trying to get the thread started, it can be a bit challenging. So there we go. Let's tighten these up. And there is our case assembled. We have our SO239 ready for connecting up, our output terminal post ready for connecting up, our lifting eye already mounted into the box. Obviously we have two more gold plated nuts which can go on here. Now what I'm going to do is I'm going to use these as locking nuts, so I'm just going to tighten them down on top of the two existing nuts that are wired up down the bottom there, and then lock them off against the original first nuts, like so. And then obviously I'm going to solder directly to the posts. And obviously once it's all completed, the lid is on, and that's actually what the finished product will look like. Now we have to move on. These are the little screws that came with the case. Now we have to move on to, let's clear some workspace here. Little handy pin vise there, as I say, very easy to get your holes lined up accurately. In my case, unfortunately, I got them a little too accurate, so they were very tight, and a little bit too precise. As I say, you kind of want a bit of tolerance. So yeah, you wanna. This is why it's important to deburr things and whatever, because those burrs, if you get them too accurate, those burrs set that 0.5 of a millimetre out, and that 0.5 of a millimetre can become an aggravation. But nevertheless, so this is going to be on our RF choke. Now what we need to do is we need to get a piece of scrap paper, or well, maybe not even scrap paper, maybe a nice fresher paper or a notepad or something of the sort. I'm going to just pull a sheet out of the printer. Like so. Let's just fold it in half. We don't need a full A4 sheet. This is some better basis to write on. So now then, what we got is we get a pencil, and what we need to do is we need to measure with our trusted vernier the dimensions of the ferrite ring, and the thickness here we've got is actually 10mm. So if we look at a cross-sectional area here, this is what we're looking at. This piece here is 10mm, and then we have to look at this dimension across here, which is the thickness in it, which is, according to this, 9mm. So 9mm there, so it's effectively 10 by 9 is its cross-sectional area. Now copper wire, when it's bent, because of its thickness of copper wire, will have a radius to to the copper wire once it's bent. Now you can work that out accurately, as I say. I mean, if you've got a Zeus book, which I've got, I'm not going to bother pulling it out because we don't need calculations that accurate. But you could calculate the bend radius of how much is going to be there using your Zeus book and then add it together. But all we really need to do is get ourselves into the rough ballpark of the length of the cable that we're going to need. Now what we're going to do is we're going to be doing 14 turns in total. There are going to be 7 turns on this side. It's then going to go across through the centre to the other side, and there's going to be another 7 turns on that side. So 14 turns in total, and that's including the one that goes through the middle. Now the one that goes through the middle is liable to be a little bit longer than just that's running round one turn around the toroid. So what we're going to need to do is we're going to need to calculate the perimeter. Now the perimeter is easy if anybody remembers their maths. So say all we do is we basically add up the lengths of all of it. Now if you look, there's going to be another 9mm up the top there. This is going to be another 10mm because it's exactly the same as that side. So effectively, you can either add it up 10, 9, 10, 9, or you can basically multiply that by 2, and then add them together. So if you got 10 times 2, which is equal to obviously 30 then, 20. Then you've got 2 9s, so that's 9 times 2, which is equal to 18. Or then what we do is we basically just add the 20 to the 18, which obviously gives us 38. Okay, now, yeah, you could round this up and say 10 or by 10 or whatever. So effectively, 1 turn would equal 40mm of wire. That would include the bend radius or whatever. So we can, in that assumption, taking that bend radius into account, we can actually assume the approximate value of 40mm of copper wire to 1 turn. We want 14 turns in total, so that would be the 40mm multiplied by 14. But we also need a length of copper wire to connect to our terminals. So there's a length of wire here and a length of wire that's going to be here to connect to these terminals. Now, I usually, I mean, you could use any value if you want to, but I usually use 100mm, which is 10 centimeters, or in imperial, that's approximately 4 inches. So you do your value here. You come out with that, which I can't do in my head right at the moment, as I say. So we'll get the calculator, we shall calculate that value, then what we will do is we will add 100mm for one side, 100mm for the other side, which is 200mm altogether. So we shall take that value there and we shall add 200mm to it to equal the length of copper wire that we are going to measure out and cut to wind onto this toroid. So let's go get the magic calculator. It's good to get yourself a scientific calculator like this one, because when you come to measure wavelengths and work out capacitances in parallel and resistance and so on and so forth, you don't have to do all the manual by hand writing it out, blah 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 blah. With a calculator like this, and this is the FX991ES Plus, it allows you to do all of your square root and squaring functions, logarithms, and your engineering points, which is your times 10 to either 6 to the, which is your mega and micro, times 9, which is your giga and nano, and then 12, which is your pico, etc, etc, etc. So you can actually add that in there on the screen as it lays out at the top. It's pretty much write it into the calculator like it's written on a piece of paper, and then the calculator does the calculations for you, which is it's an absolute time saver. But in this case, so what do we have? We have 40mm, and we have to multiply that by the 14 turns, which gives us 560. millimeters, so that's 560 millimeters, which effectively is what, 56 centimeters, isn't it, which is just over half a meter. But we need to add 200 mils to that, so we shall add 200, which gives us the total of 760 millimeters. You could turn that if you wanted to and round that up to 800 just to have the extra bit. That you're probably going to have too much copper wire waste, and copper wire isn't necessarily the cheapest of things to buy at the moment. As I say, copper being the price that it is, and you know, I mean, to be honest with you, copper is actually quite cheap at the moment. But the wire manufacturers, they've got used to selling the copper wire at the higher price when copper was higher in price by its weight, and because they've got used to that, they've kept the price the damn same, even though the price of copper has come down. And this is the problem with the commercial sector, is that, you know, they have to keep their stocks and shareholders happy, and that means more profit. If they buy in at £10 stocks a share, they want to see a return of £20 back, you know, so they've got to increase the sales of the company or whatever to match that. So they can't go and start reducing the prices unless they're drastically not selling the product, and they've got to, you know, balance the books basically to keep the stocks and shares market happy, which is not good for us, because that means copper wire goes up in price, costs us more money, and effectively turns something that's a hobby and fun into something that's incredibly expensive, that, you know, we just don't have the money to be able to, you know, continue buying huge amounts of this stuff. So, you know, again, it's good if you're doing a project, it's good to make something that's not, you're not going to throw away or whatever. It's good to put that investment in or whatever, and make sure that you do the project right, you know, similar to what we're doing here. But so we've got 760 millimeters, which is the length of copper wire that we're going to measure out. And then what we're going to do after we've measured out each 760 mil, we need 2 of them, because with this design, what's going to be wound around this ferrite core is 2 pieces of copper wire in parallel next to each other, and they're going to go around 7 turns here, 7 turns there. So you're going to have effectively a toroid with 2 wires coming in, winding their way around, obviously both wires winding their way around. It's going to go across like that, come around there, and then you're going to have the 2 wires coming off. So that one, that one, that one, and that one. Obviously this is an AC signal, that's just there to give you an idea of it going in and then coming out. There's no actual transformer action happening here. It's all to choke out unwanted noise and signals and all sorts of different things that could cause interference. That's all this is, because this is a balance. This is going to be a balanced half-wave antenna. You're going to have the equal length one way and an equal length of wire the opposite way, you know, in the antenna arrangement. So this is literally just to suppress, that's the correct word, to suppress noise and you know, interference and so on and so forth that's going to come back down the coax line. So that's all we're doing here, and that's what we're going to do. So we've got 760 mil. I shall go and get that measured up, cut, and start winding this. So yeah, see you again shortly.